Okay, I'm going to go through a review of the first three chapters, chapters 1, 2, and 3. Um, Remember to make sure you go through the notes and stuff and then have stuff ready when you take your test because you get to log on once. You got a time limit, and once you log out, you're done, you guys. So make sure you're ready when you start taking your test. All right, so chapters 1 through 3 is our first unit. On the two types of matter, remember matter is everything we study in chemistry, and the two types would be pure substances, which is elements and compounds, and then mixtures. Mixtures of pure substances, basically. The way to tell them apart is a pure substance's composition is always the same, always. Mixtures, you can vary, okay? That's why I know tap water is a mixture, because tap water isn't always the same. Every town's tap water is different. So remember that. Mixtures, you can vary the composition, pure substances you can't, okay? How can you tell the difference between a pure substance and a mixture? Well, that was one thing. That you can, a thing with a mixture is you can separate it by physical means. Sorry about that. If I have a mixture of salt and water, I can boil off the water and have my salt back, okay? If it's a chemical compound, if it's a pure substance, it's not, you have to do a chemical reaction in order to separate them, okay? But if it's a mixture, it's easy just to use physical means to separate them. Sometimes you can filter them, sometimes you can boil them off, sometimes you can just look at them, you can just tell. So if you can separate them easily, it's a mixture, okay? Classify each of the following as either an element, compound, heterogeneous, and when I say homogeneous mixture, remember that's the same as a solution, you guys. So air, a lot of people tell me that's a compound. The air in the room you're in right now is not the same as the air as the room I'm in. So air varies. That is, air is actually a solution, okay? It's a well-mixed mixture. Soil, you can definitely see different parts, so that would be a heterogeneous mixture. Water, well, if it's pure water, it's a compound. If it's tap water, I should have been more specific. Sorry, guys. If it's tap water, it would be a solution, okay? Soup, unless it's broth, it's going to be a heterogeneous mixture because you can have different stuff in there. Oh, here I have tap water, so I guess this must be pure water. This is a compound. This is a mixture, okay? Salt is a compound. It's made out of sodium and chlorine, okay? Copper, you can find it on the periodic table. It's an element, okay? Aluminum foil. Aluminum foil is actually an element made out of aluminum, okay? Aluminum is a great element. It's very, very malleable. They use it for all kinds of stuff, okay? But it is an element. Chalk's fancy name is calcium carbonate. It's a compound, okay? Kool-Aid. It's a mixture, right? You add sugar to it. You add the funny Kool-Aid mix that gives us its color. But I would say it's a solution because you stir it up and you mix it up because really you don't want your Kool-Aid to look like it has different parts to it. That'd be gross. So Kool-Aid would be a solution. A salted nut roll, definitely a heterogeneous mixture because you can see the nuts, you can see the nougat, you can see, all that good stuff. Chocolate is a solution. That sounds weird, I know, but chocolate is a well-mixed mixture unless you've got like almonds and nuts and stuff in it. But if it's like a Hershey's chocolate bar, that would be a solution. Milk depends on what kind of milk you have because you got skim milk, which is pretty well mixed. You've got whole milk, which has layers in it. So honestly, with milk, it can either be a solution or a heterogeneous mixture depending on what type of milk, because we got so many. And now we got almond milk and we got cashew milk. There's so many different kinds of milk now. Who knows, right? Jewelry is, believe it or not, a solution. It's called an alloy. It's a mixture of metals, but it's well mixed because you don't really want to see different parts there. Okay, s'mores would definitely be a heterogeneous mixture. And I don't know about you guys, but we need to take a poll. Do you like your marshmallows burnt or do you like them toasted? I'm a toasted person. I don't like them when they get burnt, but maybe you do. And last but not least, we got calcium. Calcium is an element. And again, it's on the periodic table. I know that. Okay. What phase of matter has no definite volume but definite shape? No definite shape, sorry. Has a definite volume but no definite shape. Geez, I gotta learn how to read. So if it has a definite volume but no definite shape, it takes the shape of its container. That would be a liquid. Remember, a solid has definite shape, definite volume. A liquid has definite volume but no definite shape. And a gas has no definite volume and no definite shape. So it's just because the particles are moving farther and farther apart. Okay? We talked about metals, nonmetals, and metalloids. And this is very important when you're talking about the elements and their jobs. Okay? So which one's a conductor? Definitely a metal. That's what we love metals for. Luster means it's shiny. Well, think of a metal. Yeah. Semiconductor. Okay, semiconductor would be the metalloids. Remember, those are the ones that gave us all our cool toys, our computers, our cell phones, our video games, everything. Semiconductors, and those are the metalloids, especially silicon and germanium. Antimony, I have to look on a chart. SB, I think it's a metalloid. Okay, remember that line. There's only 6 metalloids, so you know it's not too hard to get them. Malleable means you can hammer it into sheets. Okay, that's definitely a metal. You try to hammer a non-metal into anything at all, you're going to get is dust. All are solids, believe it or not, that's not metals. Because remember, we've got mercury. Mercury is a liquid. So the only group that's all solids is the metalloids. The largest group, by far, the metals. Okay, insulators, those are non-metals. Most of the time when we have like a pan, we have the pan made out of metal because we want the heat to get into our food, but then the handle is some sort of plastic or rubber. Those are made out of non-metals because you don't want to burn your hand. So we usually use a combination of the two. Okay, aluminum is a metal. Titanium is a metal. Okay, chlorine is a non-metal. It's a gas. Germanium, like I said, that's one of the important metalloids. It gives us our semiconductors. Many are gases, definitely the non-metals. Okay, we got hydrogen, we have oxygen, we have nitrogen, and then the halogens, chlorine, fluorine, bromine, you know, those guys, okay? And then all the noble gases, they're all gases, okay? Silicon, metalloid. Phosphorus, non-metal. Hydrogen, remember hydrogen is a non-metal, but it hangs out with the metals. Hydrogen is really a rebel, okay? So most of the non-metals are on the right-hand side of the periodic table, except for hydrogen. The metals are the all left in the bottom part, and then the metalloids are in between them, okay? And then iron would be a metal, iodine would be a non-metal. So make sure you know those on your table. You can even mark them if you want, color them in, whatever, okay? Significant figures, remember when we take measurements, we have to make sure when we do calculations that we report our answer in the proper significant figures. In other words, we need to make our calculation as accurate as the measurements we took. And in order to do that, we use significant figures. So this one would have 2. These guys aren't significant. They're just placeholders. This would be 2. This one, we count them all. Because anytime you write a decimal and you write numbers after, well, why would you write these last 2 numbers if you didn't measure up to that point? So this one would be 1, 2, 3, 4, 5, 6, all of them. This one, it would be these 3 because they're non-zero numbers, and these 2 because they're in between non-zero numbers. But because I didn't write a decimal, I didn't measure up to this point. So this would be 1, 2, 3, 4, 5. These 2 wouldn't be significant. This one, count them all. Because again, why would you take the time to write a decimal and write a 0? Your instrument measured up to that point and it just happened to fall on 0. Okay. This one right here, all of these are just placeholders. This would just have 3. So zeros after non-zero numbers count if the number is less than 1, but the ones before don't. So this would just be 3. Same with this one. This one would be 3. Okay. This one, because I haven't written a decimal, this is like an estimation. There was like 520,000. If this was exactly 520,000, I'd write a decimal here. But there's no decimal, so this only has 2. This only has 1. Again, no decimal. If I wanted to be 3, I'd write a decimal. But since I didn't, there's only 1. So I rounded, basically. And this one, there'd be 4, because I took the time to write the decimal and another number. These all count. So again, significant figures are really important when you take measurements. Okay? So if I added these together, oh, I didn't do them. Okay, I guess I got to do them with you. Okay, what you would do is you would add them together. So for instance, this first one, now I got to find my calculator on my phone. Okay, the first one, when I add it together, 32.15 plus 11.1, you get 43.25. But see, this goes 3 past the decimal, and this only goes 1 past the decimal. So you need to write 43.3. You have to round it so it only goes 1 past the decimal. When you add these 2 numbers together, same deal. Once you add them together, you're going to get 69, 70, I guess, 0.085. Okay, but this can only go 1 past the decimal, so you're going to have to round it. And then the same with this one. This one goes 2 past the decimal. You just subtract these 2 numbers, and then you look at your answer. This goes 2 past the decimal, and this goes 4 past the decimal. So make sure you only go 2 past the decimal. You round it to that point. Okay, remember when you multiply and divide, it's the number of significant figures. So that first one is 4 0.06 times 7. The answer is 28.42. Okay, this has 3 significant figures, this only one has 1, so I can only have 1 significant figure. So instead of 28.42, I write 30, no decimal. That would only have 1 significant figure, and it would be close to that number. Okay, the next one, 11.23 times 6.3. The answer is 70.749. Well, I can only have 2 significant figures. So I'm going to round that. Instead of 70.749, I'm going to round it to 71. You do the same thing when you divide. Divide the numbers and then round. This has 3 significant figures. This has 2. So make sure your answer only has 2 significant figures. And this one, you divide it, like, let's see, I'll do this one. 9.6587 divided by 4. You get 2.414675. It can only have 1 significant figure. So you just write 2. Okay? All right. And here we've got some conversions. If I want to change centimeters to feet, I start with what I know. Feet, 1 foot, 12 inches. That's a conversion factor. And I know 1 inch is 2.54 centimeters. So this times this times this. And you don't have to divide by 1 and divide by 1, you guys. But look at my units. Feet cancel out, inches cancel out, centimeters, and that's what my question asks. Okay? Oh, I didn't even do it. Sorry about that, you guys, but you can do it. You get my idea. Okay? What is the density? Remember, density is mass divided by volume. I have the mass 37. I have the volume 140. Okay? So I'm going to take 37 divided by 140. And this is what I get for my answer. But now, this has 2 significant figures, and this has 2 significant figures, so my answer can only have 2. So I'm going to take this big, long number, and only 2 significant figures would be 0.26, and then put in your units, grams per milliliter. Okay? Yeah, I think on these ones, I have named the following, but really all you need to know for your test is, we're going to do naming later, is how many do I have in here? This compound is made out of lithium and oxygen, 2 lithium, 1 oxygen. Okay, I don't think I need to go through this a lot. It's pretty self-explanatory. Like this one, there's 2 silver, 1 sulfur, 4 oxygen. Okay, name one thing that isn't matter. Well, energy, light, your thoughts. Pretty much everything else is matter, you guys. So when you are a chemist, you study almost everything. Okay, let's see. Name 2 elements that are liquids at room temperature. Look on your periodic table. They would be bromine and mercury. They're the only 2 elements that are liquids at room temperature. All the rest is either gases or solids, and most of them are solids. What phase are most metals? Oh, there's my next question. They're solids. Okay. What's a positively charged particle called? A proton. Okay. And here we're looking at oxygen atoms again. Well, this one doesn't have anything in parentheses, so this would have 3. Even though they're written out 2 separate, there's 2 here. Here we'd have to multiply. 4 times 3 is 12. Here we'd have to multiply 2 by 3, or 2 by 3. 3 times 2 would be 6. Okay? And if I ask you what's in this compound, it's iron and it's oxygen. It's hydrogen and carbon and oxygen. Titanium, sulfur, and oxygen. Copper, nitrogen, and oxygen. And I think that might be it, you guys. Oh, no. Oh, the families. Remember, and I'd write these out on your periodic table. The first column is the alkali metals. The next one is the alkali earth metals. Then go over and you've got your, from fluorine down, you have your halogens, you have your noble gases. Okay, so write those in, and they're in your book. On that periodic table I told you to write these things down so that you know. So lithium is in the first row, so it's alkali metal. This is the second, is alkali earth metal. Argon is a noble gas. Sodium is alkali earth. You just have to find the element and what row they're in. And that'll be on the test. So make sure you have that information ready for you. Color it on your periodic table or whatever. Okay. And I think now we might be done. Yeah. Okay. So make sure you're ready. Get that periodic table ready. Get the information on it. And hopefully you'll do really well on this test. If you have any questions, again, email me, let me know, and I will do my best to help you. And good luck.